So we're going to look at finding an unknown side in a right-angled triangle. And this will involve using the three trig ratios that we learned about last term, being sine, cos, and tan. Okay, so sine is equal to opposite over hypotenuse. Cos is adjacent over the hypotenuse. And tan is opposite over adjacent. So so, ka, toa. Those three ratios are really important and will help us to find the unknown sides. So we've got a right angle triangle here. We're going to label each of the three sides with either O, A, or H. So you can see we've got 58 degrees here. The one that is opposite that angle, we're going to label with O. This one is the hypotenuse. So the side that is opposite that right angle is always going to be the hypotenuse. And the one that's left over is your adjacent side. Now, of those three, O, A, and H, which one do we not have any information for? And we don't know what it is, we don't care about it, we don't want to find it, there's no number or letter there. And that would be O. So if I scribble out O, we're left with A and H. Which one of the three is adjacent and hypotenuse? It's going to be ka. So then we write cos of the angle 58 equals x over 15.2 because it's A over H, adjacent over hypotenuse. Now we want to know what is that value here. This is x divided by 15.2. What's the opposite of dividing by 15.2? It's timesing by 15.2. So x is equal to 15.2 times cos 58. Now you get the calculator. So 15.2 times cos 58 equals 8.05. So we'll say to 2 decimal places, and it's in meters as well. That's why I wrote 2 dp there. So just round it to 2 decimal places. Now, also make sure that when you're doing this, your calculator is in degrees mode. It usually is, unless you've been doing any statistics or if there's a R there, that's bad. You want to have it in degrees mode at this level so you can see there's a degrees mode there. Okay. All right, so example 2. And I probably should have in here written out a few lines. I'll do that in the next example. Written out a few numbers and then rounded. We'll do that next. So in example 2 here, step 1, label with O, A, and H. So we've got H, the hypotenuse. It's always opposite the right angle. The other one is opposite the angle that we've been given. And this one here, the one that's next to it, that's your adjacent. So of O, A, and H, which one do I... There's nothing written there, there's no letter, there's no number. I really don't care what it is. And that would be A. So we're left with O and H, which means it's going to be so, or sine. So sine 33 equals O is first, O goes on top. So in this case, we're looking for the letter P over 20. That's P divided by 20. So I want to times by 20 to work out what P is. 20 times sine 33. Okay, getting out the calculator. 20 times sine 33 and 10.892, blah, blah, blah. Rounding to 2 decimal places. So 10.89, and again, we're working with meters. So we'll say meters. Okay. The next one, Again, labeling with O, A, and H. So we've got our angle here. The one that is opposite the angle, we put an O. Opposite the right angle is H, and the one that's left over is A, your adjacent side. Of the three letters, the one that has nothing there is H. So we've got O and A, which means it must be TOA. So 10, 23 degrees, 18 minutes. O is first, O goes on top, over the 47. Okay, and again, just timesing. And really, once you do a few of these, you don't have to write times 47 all the time. You can just write down Q equals 47 times 10, 23 degrees, 18 minutes to save a bit of time. Okay, so 47 times 10, 23 degrees. Now this time we don't just have degrees, we've got degrees and minutes. So we need to use the bubble button, which is this one here. 18 minutes, then closing the bracket. Okay. And so we get 20.2413. So rounding to 2 decimal places, 20.24 centimetres this time. Now, it won't always be that they'll give you a picture. Sometimes they'll give you a sentence or a real life scenario and you have to draw a picture to match that, which can be the trickiest part. So we've got a triangle. JKL is right angled at K. So before I even go and read the rest, I'm just going to draw a right angled triangle. I don't care what length that is, It's just a general idea of what it might look like. So I want a right angle at K. Side JK is 35 and angle J is 63. Well, looking at my picture, I've kind of drawn this angle, looks a little bit bigger, so I'll put 63 degrees there. J and JK is 35 meters, that's a length. Find the length of L, so L is the only one that's left. Find the length of LK, we'll call that X in there, to the nearest meter. Step 1, labeling with O, A, and H. So we've got the one that's opposite the angle we've got, that's O. Opposite the right angle is your hypotenuse, H, and whatever's left is A. Which of the three do we want to cross out? We're going to cross out H. So being left with O and A would be TOA. So 10, 63 is X over 35. We've got divided by 35, so we're going to times by 35. Okay, getting out the calculator. 35 times 10, 63. And to the nearest meter, so we'll write out what it is first on the calculator, then rounding that to the nearest meter, that's going to round up to 69 meters. Okay.